Hello and welcome. My name is Brian Motherway. I am Head of Energy Efficiency here at the International Energy Agency. And it's my great pleasure to welcome you all to today's workshop, Strategies for Digitalization of Electricity Systems. Thank you all for joining us in what I think is going to be a very interesting discussion today. These days, we can't talk about the future of electricity systems without discussing the two key themes of clean energy transitions and digitalization. Both have profound implications for how electricity systems will be designed, operated, regulated, and run in the future. We know that countries around the world are looking to electricity systems to lead the charge on clean energy transitions through greater degrees of electrification, but also much higher penetration of renewable resources, which in turn has implications for flexibility, for how systems are run, for how operators are remunerated. And digitalization will be central to unlocking the potential of grids of the future to be a key player in clean energy transitions and to provide vast amounts of clean power and clean energy to citizens all over the world to make their lives better in the context of a more sustainable and decarbonized energy system. We at the IEA are working with governments all over the world to understand the kinds of policies, regulatory environments, market design, technology issues that they face if they want to unlock these potentials. And we know that market operators, companies, utilities, and many others are also engaged in these discussions. And we're very pleased to be able to be part of these discussions with stakeholders and actors all over the world. And in particular, this workshop brings together two initiatives that are both very important. First of all, the Power System Flexibility Campaign of the Clean Energy Ministerial, which is led by China, Denmark, Germany, and India, and is working with countries around the world and other actors to help understand how to accelerate system transformation by increasing flexibility across the whole system. Secondly, we are also here in the context of the IEA's initiative on digital demand-driven electricity networks, 3DEN for short. Which we are grateful for the great support we get from the Italian government to help run this initiative. This is focused on understanding the kind of steps that governments can take through actionable measures and policies to increase investment in digital technologies in grids and help unlock the potential for greater levels of efficiency, system optimization, and of course, clean energy. Both of these initiatives share many interests in common, and we are here to discuss them today. And we are also here today to bring many great speakers from many parts of the world that will share their perspectives. I particularly want to tell you that this event and these discussions today take place in the context of some very important work going on here in the IEA to look at how to accelerate clean energy transitions, and in particular, what it might take to deliver net zero emissions from the global electricity system by 2050. On the 31st of March, the IEA COP26 Net Zero Summit will take place, co-hosted by the Executive Director of the IEA and the President of COP26, and will bring together world leaders and ministers from all major countries to discuss how to accelerate progress towards net zero emissions in the energy sector. And in parallel, in May, the IEA will launch a very special and unique report, The World's Roadmap to Net Zero by 2050, we'll look for the first time comprehensively at what a net zero emissions energy system can look like by 2050 and what actions need to be taken to get there. Certainly, in my view, electricity will be central to that. Digitalization will be central to that. Renewable electricity, demand side flexibility, all of the issues we're here to talk about today will be central if we want to deliver on these ambitious but essential goals for all of global society. So this workshop will provide insights into what we've learned to date, what experience people can share, and what actions are suggested from all of our major players discussing things today to see what is needed to move us forward. In the context of our close partnership with Italy, who is already showing itself as a leader in this space, it is my pleasure now to introduce to you Luciano Martini, who's the Director for Transmission and Distribution Technologies at RSE, to say some opening remarks. Luciano, you're very welcome and the floor is yours.
Thank you very much, Brian, and good morning, good afternoon, and good evening, everyone, and welcome to this interesting workshop on strategy for digitalization of electricity system. I would like to thank you, Brian, for these opening remarks. Excellent. You already covered all relevant aspects, underline the main focus of the 3DEN initiative, and also mentioned the strong support from Italy to this initiative. Hence, I will use my time to underline and reaffirm Italy's innovation strategy that is based on an energy and climate integrated approach. And I would like to thank the IEA and the PSF campaign for organizing this event and for providing Italy with this great opportunity to contribute to this welcome address session. The first aspect I would like to briefly mention is the Italy's strong commitment to support international cooperation. Initiative and action in this direction are fully in line with the IEA, but also in line with Italy's active participation and contribution to key global initiatives such as the Clean Energy Ministerial, Mission Innovation, and ISGAN. And this is also at the basis of excellent collaborative effort that is carried out by the Power System Flexibility Campaign. We strongly believe that international cooperation and the related exchange of information, exploitable results, and best practices is the most efficient and effective approach to address global and complex challenges and to accelerate the development of a needed solution to be implemented to modernize the electricity and energy systems at large. Italy is particularly keen to fostering smarter and low carbon electricity system and to use the best available technology to contribute to this ambitious goal, including providing financial and technical support to other countries, as well as a bold action toward effective international cooperation to properly face the present and also the near future grand challenges. The second aspect I would like to briefly touch is the energy and climate integrated approach we adopt as Italy and as Europe Union at large by developing our national integrated energy and climate plan that set the targets and the energy and climate objectives and very ambitious goals for our country by 2030. Therefore, initiatives such as the 3DEN represent a great opportunity for us and for countries that want to increase their ambitions to tackle with climate change and want to define an innovative integrated approach since energy and climate are now really closely interlinked. We have worked with the IEA and made significant progress on the 3DN project. The regulatory and technology context analysis is there. Strategic areas and also the place where a pilot project could be placed are defined. And moreover, we create an advisory board that is including experts from all over the world. I would like to mention that this initiative will really get very, very high visibility during the G20 presidency of Italy, and we will mention this initiative in different contexts in order to gain visibility and importance to the initiative. I think it's important to listen to all important contributions from all members from around the world to this workshop. So I stop here. I wish to all of you to have a very fruitful workshop today. Thank you. Thank you, Brian.
Thank you, Luciano. Thank you very much. And a warm thanks to you and, of course, to Italy as a whole. It's great to hear of the ambition you have for Italy, but also in your global leadership position. And as you mentioned, both as co-president of COP this year and president of G20, Italy is taking on such a strong burden of global leadership. And we're very grateful to you, and we enjoy and look forward to enjoying further working with you throughout.
Thank you so much for your kind words.
Thank you, Luciana. Now, let me turn now to my colleague, Alejandro Hernandez, who's head of the Renewable Integration and Secure Electricity Unit here at the IEA, who's going to start us off proper. Alejandro, the floor is yours.
Thanks so much, Brian. I will present a few slides in order to provide the background discussion for this event. As soon as they show. Thanks so much. Thanks so much. As was already mentioned, we are today having two initiatives that are managed by the IEA. It was already mentioned by my colleague Brian. The importance, the relevance that has the work on the Digital Demand-Driven Electricity Networks Initiative, which is kindly supported by Italy, and in which we have a lot of hopes. This session is part of the events that is one of the intermediate outputs of this initiative. And also, as it has been mentioned, we have a lot of also a work that has been done on the power system flexibility campaign. This is an effort that is reaching the third year, which has had a lot of publications as a result. These publications, they focus originally on the hardware part of the power system flexibility, for instance, like the thermal plants. But as the time goes by, it is more and more important the fact that many enabling frameworks are as important as the hardware. So market design, digitalization, and sector coupling. And this is where this event comes in together and into the relevance of the digitalization for the future of the power system. As we all know, the world is still far from putting emissions into a decisive decline. So on the current scenario, on the STEPS scenario from the IEA, on the stated policy scenario, the global emissions are still set to bounce back, even if there is more. This is going to be slower than in the financial crisis of 2008, 2009. And this is still very far from our shared global objectives on decarbonization. And this still will lead at least to a 3 degrees warming of the global climate. So, sorry. When you compare this to the sustainable development scenario objectives, there is still a large gap that we have to fill. Even when we consider already very ambitious objectives set by many countries like the UK, New Zealand, the European Union, and others, their reductions in emissions are still far from what is needed. More recent announcements, like for instance, like the one on China, on the net zero on 2060, is still be less than half of what is needed. The IEA has modeled and proposed a path in order to get the objective, the sustainable development scenario objectives on decarbonization and energy access and health. And we have also considered the options that are included in order to get into the net zero in 2050. So this is something that is feasible, but that will require taking all the possible instruments that we have at hand. And this is where the digitalization of the power system kicks in. A very important part of the power system need to be changed on all the possible segments of the value chain. In particular, the grids, it's a very important part. If we compare what is needed in this kind of scenario, in a highly decarbonized power system scenario, we need to still invest a lot into our distribution and transmission grids. Actually, the amount of kilometers that is still needed will be 80% larger than was done in the last decades. It's not only that we will need more grids, it's not only the hardware, but besides, as we can see in these green dots, it's not only that we need more lines, we need also smarter lines, or we need smarter grids in general. So for the transmission system, it would require digitalizing at some extent, going from 7% to 15%. This is a 100% increase on the digitalization part. And for the distribution part, the increase will be of 50%. So it requires a lot of effort. And what is this? What are the kind of elements that we can expect to have from these smarter grids work? The, the benefits come from in many different ways. For instance, it can come from the fact of having real-time communication from smart meters in buildings, which can lower the peak demand up to 8.9%. This can improve the weather forecasts and reduce the curtailment of wind generation by 10%. Already today in the US, the estimates are that the demand response programs established all over the country save around 1 to 4% of the peak demand across each balancing authority. And if we had in 2030 only 5% of the world's EV chargers capacity to interact in a smart way with the grid, that would already be equivalent to 600 gigawatts of peak demand. So these are some of the technological possibilities and the outputs that we can get from getting a digitalized and smarter power system. So the next question comes into how do we maximize these benefits? What are the kind of benefits that we are getting? And I think it's relatively easy to find the cost benefit part. We can have from environmental benefits. Of course, when we have increased VREs, when we can reduce the curtailment of variable resources, we can have, in general, improved system efficiency. For instance, having optimization of investment plans. It's very expensive to have one plant that is going to be used only a few hours a year. So this costs a lot of money to the ratepayers. We can have improved quality of service. We can have the reduction in time that it takes to address faults. We can reduce a lot the time in which this kind of problems of outages are solved by the system. And we can even avoid them with much better predictive maintenance. But overall, all these kind of elements, they should result in lower cost of service for end consumers. So it is very important to define strategies to understand what are the policy objectives and what is the right instruments that we need to implement. So there are many kind of benefits, and we should think on all these kind of contexts when we are talking about strategies for each country. So you can have these kind of benefits on the billing optimization of benefits. That's, for instance, when you have a consumer that is avoiding network charges, or in the case of a related utility or in the independent retailer, you can have energy credits from net billing or from net metering. Now, other kind of things that are valid for in a competitive market or for a regulated utility, like the fact that you can have reduced maintenance costs. So you can have as well the improvement in the network operational and maintenance costs. You can have reduced transaction costs, and you can have lowering dispatch costs. The costs and benefits, they come no matter in which kind of system you have. If it is a regulated system, if there is a wholesale market with competition on the retail side, or you don't have competition on the retail side, the benefits are there, which is the main point is to how do you align the incentives from all the relevant stakeholders for these benefits to be concrete and to actually get done. So that's the main point, and that's where the trick is. There are no two power systems that are the same. They don't have the same structure, and they won't have the same benefit, by the way. So depending on the characteristics of each system and in the institutional framework, the strategy will be different, and the kind of technologies that you will be needing, they will be also different. So just to finish, I will leave a few key points for discussion today. So we have this digitalization at various points of the power system that can lead to multiple benefits. How can these benefits of digitalization be maximized through strategies? And the next one, the digitalization in the power system will enable links with other sectors of the economy, like water, for instance, and other areas of policymaker? And what are the kind of considerations that we should keep in mind when designing these digitalization strategies and when linking with other areas of the policy arena? What about acceptance and uptake? If we want to have successful development, what are the design options that are there in order to ensure that customers, users accept and engage with these opportunities? The shape and benefits of digitalization, they depend on a large extent on the local market and the characteristics of the system. How are the technology providers adapting to these characteristics? And finally, what are the key elements to ensure that this is also contributing to other key aspects of energy policy? Security of supply is one of those, and cost effectiveness, of course, this is I would say, the one that comes to mind the most often. So I would leave you here with these key questions. And now we will pass the floor to my colleague, Enrique Gutierrez, for him to moderate the session. Thanks so much.
Thank you very much, Alejandro, and also welcome to everyone who's joining us online. So to answer all the questions that Alejandro put, and we hope that this session is helpful for all of you to, either you're a policymaker or you're working advising on digitalization strategies. We hope that these questions will help you shape your plans and actually maybe give you new things to think of when you're devising your plans. And to start answering this question, we're going to start with our first panelist, who is Matthias Böswetter. He is from the German Energy Agency, and is currently senior expert for digitalization and security. He's going to tell us a bit about the German design strategy that was focused on cybersecurity and privacy. So Matthias, we're going to move to your slide now, and if you can share your camera, welcome very much, and thank you very much for being here with us.
Yeah, thank you very much for this kind introduction, ladies and gentlemen. I'm looking very much forward to this event. However, I have still problems to start my video. Now I can do it. Thanks very much. Yeah, today I want to talk about the smart meter gateway, and I think the solution we are implementing right now in Germany is also a good example for a solution that is driven by this idea of privacy and security by design, which means that this is not an afterthought to a whole new digital infrastructure, but it is in the very DNA of this new infrastructure. Why is that so? Just a moment. No, I need those rights, and I think now it's working, maybe with a bit delay. Perfect. So the energy transition in Germany, the Energiewende, is, as said before, related to the overall design of the energy system, which is always a unique thing. That was said before. And in Germany, the Energiewende comes with a shift towards the distribution grids due to the very decentralized nature of our energy system. However, at the latest, the cyber attack on the Ukrainian distribution grid in 2015 showed that grid infrastructure offers an attractive target with high disruption potential for the economy and the social life of a modern industrial nation. Due to the higher and rising degree of digitalization and grid management, and the importance that guaranteeing security of supply has for a modern industrial society, the importance of grid infrastructure for cyber attacks will also increase significantly in the future. In Germany, as I mentioned before, the decentralized nature of the energy system and energy transition ask not only for a higher degree of digitalization, it also demanded a very decentralized approach on digitalization for integrating millions of decentralized energy resources and ensuring also the security at the edges of the grid. Building upon the guidelines of the European Directive on Energy End Use Efficiency and Energy Services, and most important, the directive concerning the common rules for the internal market for electricity, the German regulators opted therefore for a far more ambitious setup and approach for metering than it was originally envisioned by the European Commission. Besides visualizing energy data, which was the original idea, the German approach envisioned a central communication platform, the smart meter gateway, allowing for a smart integration of renewable energy resources and controllable loads into the grids. The major reasons for that very ambitious solution lay in the decentralized setup, as I said, and the goals were, besides ensuring cybersecurity at the edges, also avoiding costly grid expansions, or at least keeping them to a necessary minimum in order to save money regarding grid expansion by using or optimizing the use of flexibility. This is very important when we consider the rising importance of heat pumps and, of course, electric vehicles. From the very beginning on, the whole process of implementing the smart meter gateway and designing it first was determined by a discussion concerning privacy and security. In particular, the privacy aspect was discussed in full length and with controversy with German consumer protection stakeholders. The discussion heavily influenced, therefore, the two major acts concerning the smart meter gateway here in Germany. The one is the Digitalisation of Energy Transition Act from 2016. The other is the Metering Point Operation Act, also from 2016, which is kind of the technical implementation act that based on the Digitalisation of the Energy Transition Act. Both acts are tailored around principles. Those principles you can read there on the slide, ensuring that only as much data as necessary are transmitted and that those data is kept close to the data generation node, to the gateway itself, as a default. But how does this gateway work? What's its architecture, and how is the gateway as the communication platform embedded in the whole metering infrastructure? At its core, the architecture of the smart metering system consists of this communication unit, the gateway, which connects the smart meter in the local metrological network with the various market participants and grid operators in the wide area network and the local home area network as well. The smart meter gateway ensures, therefore, all communication links are encrypted in this situation, and that only known participants, market participants, and devices are trusted for communication. The gateway administrator, which is a very important role in this whole setup, is responsible for setting up the communication connections in each case. However, besides the general layout of the architecture, the process of defining requirements for privacy and security by design was so central that the Federal Office for Information Security, alongside with the Ministry of Economic Affairs and Energy, was in charge of the whole process to develop guidelines that provided the maximum of technological openness by ensuring at the same time the maximum of the security and privacy. So the first step in this process was actually defining protection profiles. And the protection profile describes possible threats to the smart meter gateway in its operational environment and defines the minimum requirements for corresponding security measures. The structure of the protection profiles is regulated in the so-called common criteria here. On the basis of the protection profile, products can be evaluated, which receive a certificate after a positive test and thus demonstrably fulfill the protection goals. At the same time, the protection profile gives the manufacturer leeway in the technical design of the security requirements. And in doing so, it ensures that uniform high security standards are guaranteed even in the case of different designs, which is a very important point here, and ensure continuous further development of the products in the case of new technological opportunities and possibilities, and also use cases. In order to counter the threats, the protection profiles defines also a number of security objectives that must be implemented by the smart meter gateway in order to fulfill its role. And that's really important as a link between three different networks, as I described before in the architecture. The gateway seals off the network from each other. To this end, the manufacturer must integrate a firewall mechanism and solutions into the gateway, among other things, in addition to the physical and logical separation of the respective networks. The last step is, of course, the certification according to the common criteria, which are serving as a proof of the safety properties of the protection profile, and also includes proof of the safe production, which is also a very important point, and development environment of the gateways itself. It is also related to the safe distribution of the gateways to the end consumers in the end. However, this is not enough for the implementation. Therefore, to ensure interoperability of the various components present in the smart metering system environment, they must also meet purely functional specifications. Furthermore, the security in the protection profile must be specified in more detail. These additional requirements for a smart metering system and the secure operation can be found in this technical guideline TR 03109. And there are very specific paragraphs regarding for this topic very important aspects of cryptographic specification, but also the public key infrastructure and the safe and privacy privacy related administration of the smart meter gateway by the administrator. So as you see, the overall problem here is to ensure the most amount of security and privacy by giving also a very strict and a very high quality framework for security as well. As you probably already know, when you know the situation here in Germany a bit, this complex process was faced with a lot of delays, but finally we are in the process of recertification of certain gateways and a full rollout after the amendment of our Renewable Energy Resources or Source Act at the end of the last year. However, we, the German Energy Agency, already started a project that is also funded by the Ministry for Economic Affairs and Energy to test how the smart meter gateway could be used as a backbone and trust anchor for a machine identity ledger that allows for the automated registration of decentralized energy assets. Now, this so-called blockchain machine identity ledger does not only, and you see it on the slide, not only does try to test blockchain technology as an add-on to the smart meter gateway, it also incorporates the guiding principles for security and privacy by design at its core. The project allows for keeping the data close to the data generation node, which is one of the major aspects of the gateway, and allows for an automated and end-user-centric data governance in the end. In addition, it offers an immutable and distinct identity of any device, which is crucial for an energy system that then decentralized as the energy system in Germany. Yes, I think that it was. There are already some questions in the chat. Am I allowed to answer them right now?
Let's leave them towards the end. I think that would be better to also to have a discussion and make sure that we stay on time.
Yeah, okay.
Also for keeping an eye on the questions.
I hope I kind of keep the time.
Yeah, it's great. Thank you very much.
Okay.
I think maybe I'll just do like one quick clarification question about the sparing time of the readings. If you could just provide like what is meant about like sparingly spaced of the reading.
That means 15 minutes.
Okay, thank you very much. So then moving on to the other side of the Atlantic, also a PSF member that we're very happy to work with, is Carla Coronado, who is a policy advisor to the Ministry of Energy in Chile. She is she's currently part of the team leading the coordination and the revision of the long-term national energy policy in Chile. And she's going to tell us a little bit more about how they are devising their long-term energy and digitalization strategy from a different take. Welcome, Carla. Thank you very much for joining us today.
Hi, thank you. Today, I want to talk about how we are envisioning a socio-technical transformation, putting people at the center. I want to share with you the experience of energy sector policy in Chile. So let me tell you a little bit about the Chilean energy context. Can you see the slides moving forward or not? Because I'm supposed to have the control, but it's, oh yeah, that works. Okay, so let me tell you a little bit about the Chilean energy context. We have no fossil fuels, but lots of renewable energy resources. We have been heavily dependent on imported fossil fuels until recently, and we have an unbundled, liberalized electricity systems since 1982, and we were one of the first countries in undergoing liberalization. We are currently working on adding the retailing stage for electricity and its associated services. And additionally, we have no international grid interaction currently in operation. So a decade ago, we started transitioning to a system that is based on renewable energy resources. Many factors and actors played out on that transition, but one key feature is that it happened without subsidies. So the state played an important role, though, by implementing and adapting regulation and basically sending political signals to investors and the sector in general. So, and we are aiming for guiding a socio-technical transition that steers our development path towards a more sustainable way of living. And for that, we know that digitalization is to play a fundamental role as an enabler of policy solutions to reach decarbonization and, of course, decentralization as well. So in terms of infrastructure, so let me tell you a little bit that in recent years, we have taken further steps to reach carbon neutrality. Our country has committed to reach carbon neutrality by 2050. And one of the key steps we have taken for achieving this is to phase out all coal power plants by 2040, which are responsible for 25% of total CO2 emissions. And now we are making regulatory changes and thinking on how to adapt our policies in order to reach that goal. So more specifically, let me tell you how is our digitalization context now in Chile. In terms of infrastructure, we have not yet massified the use of smart meters, which implies that distributed applications are not massified either, although we have started reforms on the communication and management side of the system. In terms of security, we still have to define regulations and protocols for privacy, for data sovereignty, and the information security. And most digitalization uses still face economic barriers along with high investment costs. All this speaks about the need for several regulatory changes that we still need to make, and we need more skilled people as well. So the energy sector faces a big challenge of moving forward towards an end user-centric paradigm that allows for taking advantage of the opportunities given by digitalization. We want to share with you an experience from which we have learned a lot from. We already tried for a first time to start a massive national program for switching towards smart meters. This was in 2019. This attempt did not turn out so well because people started facing a rise in their electricity bills. The rise was small, but they did not like it because they were unable to see the benefit of such an investment in the short run. So the program had basically to stop. So of course we have sat to analyze our experience, and we want to share with you the most important lessons we have learned. First, that the way in which we communicate a solution is very important for policy success. And second, that it is necessary for people to perceive the benefit of policies. So Chile used not to have any energy policy until recently. For the energy sector, that meant a market-driven approach with minimum state intervention. But because of that and our strong dependence on imported energy resources, we faced energy crisis in the early 2000s. That helped actors of the sector realize that the state has an important role to play in guiding energy development. And since 2015, the energy sector became a pioneer in the country for launching a long-term state policy. From the beginning, this long-term energy sector policy was constructed in a participatory way, and we are currently undergoing an updating process of our long-term energy policy, and this diagram depicts that process. Indeed, we continuously try to open up and improve participation spaces, and you can see that reflected on the silhouettes of people in the diagram. And we want to stress why participation is key to us. First, because we want our policy to be rooted on people's needs and of course to address them. Second, because people need to be part of the diagnosis, but also of finding prospective solutions and weighing their implications. And third, because we need people to feel part and take part on the implementation of energy policies. For policies to be appropriated, it is key to integrate actors in the policy design process. So here are the key messages for the digitalization strategy that we got from that participatory process. In the long run, public policy should aim on electricity systems. Public policy should guarantee that all users of electricity are able to make informed decisions. And here we want to stress that since we are aiming for a desirable state in the long run, we do not focus on picking specific policies, specific technologies, sorry. And that the electricity system should be accessible, flexible, sustainable, and reliable for opening up more spaces of interaction with users. And on information, public policy should guarantee the access to energy information, and that is for people as well as for public and private institutions. So for that, we will need to develop a regulation for coordination, cooperation and security, and we'll have to have continuous data collection and management processes. So what are we doing now? We are focusing on developing regulation for assessing communication systems and information management systems before we focus back again on the much needed metering equipment. And when we tackle that again, we want to make as much apparent as possible that the benefits of our policies to people. For that, we want to wait until distributed technologies such as electric cars and solar PV at the individual level are more widespread. We are also working on a regulatory reform for allowing for electricity retailing and associated services. And so far, our approach to help unleash distribution systems and digital applications focuses on identifying barriers that prevent their adoption and deployment. On information, we have the first information management and communication systems at the ISO level. So there are, of course, still many opportunities related to digitalization. Here are some policy recommendations we have received for what to focus next in terms of our digitalization strategy. First of all, policymakers, and that means the state, are encouraged to take a more active approach. We should promote the articulation of different institutions, increase the investment in digital infrastructure, define a common data architecture and standards for interoperability, as well as to raise quality and security. We need more human capital and digital education. We need to support pilot programs and encourage private investment. So all these should help us to further advance our socio-technical transition that aims to put technology at service of people's needs for constructing a more sustainable society. Thank you all very much for your.
Thank you very much, Carla, for the great presentation. And I think just to clarify quickly, I think also based on the questions in the panel, could you tell us a little bit more about this participatory approach, the type of institutions that you brought to the table for these when you mean articulation within different institutions? Like what kind of actors did you bring together to discuss the strategy?
We try to cover all actors in the sector. That means the public sector, of course, the generators, transmission, distributors of energy, so all kinds of enterprises, but also NGOs and the civil society. So we invite everyone to the table.
Okay, thank you very much. Let's hear more about it in the discussion section. For now, let's move again to the other side of the world. We have two representatives from India. Thank you very much for joining. So we have first Sri Arun Kumar Mishra, who is from the National Smart Grid Mission project, and he is the director for it. And also he will be delivering the presentation. And then in the panel also Sri Vivek Goel, who is the Chief Engineer of the Central Electricity Authority, will also be joining for the discussion. So in the meantime, Mr. Kumar, thank you very much for joining, and the floor is yours to deliver your presentation.
Hello. Good evening and good afternoon to all. Hello, I'm not able to start my video. Can you enable that?
Let me send you a request to activate it.
Mm-hmm.
You should have a prompt on your screen now.
Right, so here it comes. And let me request for remote control, so fine. So does it start now? No.
Now, if you use your keys, you should be able to switch.
Yeah, I'm trying to start the presentation. Meanwhile, I'm Arun Mishra from National Smart Grid Mission, and today I want to share with you the digitalization approach which Indian power sector has taken and which has given confidence to the policymaker as well as to the system operators for committing the nationally determined goals of 175 gigawatt of renewable energy by 2022. So this is institutional framework for power sector in India. We are a federal structure, central and state level, policies, ministry, and of course, we have chief engineer from CEA, that is Central Electricity Authority for regulations, and state governments also follow the same. And regulatory, that's more for commercial side of it. And generation, transmission, system operator, and of course, distribution and trading. So that's the framework for institution. Now my next, okay. So the historical initiative for digitalization in India have been, they started with the GENCOs, where asset optimization and operation management was the key driver. But when it came to transmission and grid operation requirement, the Central Transmission Unit took the initiative through Unified Load Dispatch and Communication Schemes, which were from 98 to 2008, with more than 1,500 nodes. Now, of course, they have raised to 3,500 and more than 30 control center across region and states. And that enabled the market at the bulk level, where power exchanges started in 2008 onwards. Then we turned our focus to the distribution side, where operation optimization and, of course, the visibility of the asset, those were the primary targets. So geographical information systems, then enterprise resource planning, information technology for control for customer care, as well as metering, billing, and of course real-time data acquisition system for asset. So those are the numbers across the state. Various options were taken. This distribution companies, out of 80, more than 35-50% have opted for some of the digitalization effort, and we have close to 1,588 towns, which were more than 30,000 population, where these initiatives, including the GIS-based asset mapping and customer indexing, were undertaken. Now, of course, we have more than 4,000 substations where the real-time data acquisition is taking place. So that kinds of give a visibility and confidence to the system that yes, we can operate. But then we embarked on a one nation, one grid target that was from 13 to 16, where unified real-time state measurement scheme was undertaken for phaser measurement units more than 800 places, and that gives a state awareness across state and regional centers, situational awareness and of enhanced, that was supplemented with renewable energy awareness for weather forecast and of course footprint of those generation. So that was kind of 2015 where we were pretty much ready with and confident on our national grid. That brought in the capacity to commit for the transmit bulk power system, a renewable energy goal of 175 gigawatt. And then we started focusing on the consumer side. For National Smart Grid Mission, the unit at which I am working was established in 2015 for policy and programs on smart grid, mainly focusing on the distribution side, where we started with the technology for focus of funding for 1 million smart meters, and of course discovering the business case for utilities and other entities to start working on the smart meter rollout. And we were successful somewhere in 2018, and now we have more than 10 million smart meters uh, works in progress. Enthused and confident based on that success, the ministry has set a target of replacing all smart meters, ideally within 3 years. That will be 250 million smart meters. So all the consumer meters will be replaced with the smart prepaid meters, and that will set the stage for bulk enabling of consumption side participation of users in the system for enhancing that next level of renewable energy targets and retail market opportunities of energy optimization, generation balance through demand response, or EV infrastructure, which currently is focusing on electrification of transport. But the moment we have this feasibility, it will come into play for balancing and energy shift as well. So that's the technology part of it. The market part is being discovered or being attempted through demand response pilot. There are pilot projects going on for demand response at industrial, residential level, but they are basically trying to learn where or to what extent we can depend on the consumer for energy shift as well as for the load generation balance, which will come later. So NSGM has set itself a goal for aligning the systems with objectives of Government of India, reaching the better power quality measurement and management for consumers, developing microgrids for focused learning, as well as creating niche area for transaction and learn and multiplying it later on. And of course, quality of power to the consumer. Reduction of AT&C losses is one of the goals which we are very confident of achieving through smart meter initiative, which will the same infrastructure will be deployed for better peak load management and outage management as well, and for of course managing the EV infrastructure. The National Smart Grid Mission is mimicking the overall management of the sector through governing council, which is headed by Minister of Power, and Empower Committee, were centrally headed by the Ministry of Power Secretary. State level, we have matching units, and of course, technical committee chaired by chairperson Central Electricity Authority. And then we have an project management unit where I'm working for these policy and programs, day-to-day management and implementation. And we have created a smart grid knowledge center for repository of the knowledge for what we have gained from our activities, as well as every utility is in the process of setting up their own smart grid cells. Till now, out of 29, 19 states have initialized their state level project management units. That's kind of the overall goal. And this 2015 initiative was backed up by, was based on the initiative which we took in 2010, what was a smart grid task force, which was inter-ministerial policy group. So across Ministry of Heavy Industries or NITI Aayog, and an India Smart Grid Forum for Public-Private Partnership, and of course other institutions were sensitized from 2010 to 15 for taking up the challenge of a smart grid through digitalization. And we banked on our pilot projects, which we initiated 11 pilot projects, out of which all of them are operational. 1.56 lakh smart meters were installed. And it is worth sharing that when we started, we had some challenge in communication technology, but by the time we ended in 2017, a new improved version was deployed and two new developers were discovered, and sustainability of the products and deployment was some issues were seen when you go for new partners. So currently the stakeholder perspective is that yes, asset owners, they are discoms or state entities, they are looking for funding and sustainability of the investment. The funding agencies are looking for return as well as renewable energy targets. That's a policy driven goal. And regulators, which are close to one regulatory body per state, they are looking for what is in for consumers, how to orchestrate the entire program. So we have a sustainable utilities as well as the consumers have equal opportunity as and they moving forward, they participate in the system. And of course, when it comes to consumers, they are happy when the visibility gives performance improvement to them, but they are not so happy, something similar to Chile experience when it goes to energy and energy is more accurately measured, but we are able to bring some benefits to the consumers as well in terms of prepaid smart metering rollout where they have more control on their consumption, granularity as well as forecast, and that's helping bringing them on board. Pan India basis, this is the overall pipeline projects and ongoing projects is 8 million and of course 10 million in the pipeline. These can always be accessed from National Smart Grid Mission website. What we are looking forward to is flexibility of power and energy being enabled through these initiatives, and of course market and policy discovery will be formed up based on the experience of the pilots which are being undertaken. What we look forward to is from minute to hour, that's the area where some of this flexibility will be leveraged in demand response for generating a return for all the investment, because all the smart grid investment is not expanding, not bringing new customers to the grid, rather than we are changing the quality and the way we deliver. So we need to look for new ways to generate revenue for distribution companies, and that remains a challenge, and that's where some of the pilots are undergoing. And to facilitate these, I think my slide response has stopped. So okay, next slide is my last one, which showcase the Smart Grid Knowledge Center, where we are trying to have the repository of all the interventions, where cross-learning across the cities, across the consumer groups, and of course, across the discoms takes place. Thank you.
Thank you very much, Mr. Mishra, for your presentation. Definitely very interesting to see. Also, that you've targeted not only the kind of the end side of the grid edge under the smart meter side of digitalization, but also reliability and transmission. Just one question: when you mentioned the pay as you save, so who are the savings? Is it is it savings for the utilities that got the funding to install the smart meters, or is it savings that the end consumers see?
This is the savings for the utility who are funding the smart meters, because they are saving in terms of the operational cost, they are saving in terms of the revenue realization, and of course they are saving in terms of the consumer participation and the early payment from the consumers. So the asset owners can commit to the asset creation, because they need not have it does not burdens the consumer. There is no rate increase to the consumer.
Hi, Hendrik.
Hi, how are you doing?
I am Vivek Goel. If you allow, then I can also share the some of others initiative the government of India has taken for this implementation of smart metering in the country. So firstly, I will take only the 1 minute, 1, 2, 3. So firstly, in last year in December 2019, we have amended our earlier regulation, and we have made the smart metering now is mandatory, so that all the new meter which will be replaced, they will be replaced with the smart meter only. So this is a one big step. And recently in December 2020, Government of India has also issued the consumer rights rules, which allows the regulators in the states to allow the distribution companies to install the smart meter, so that the smart meter rollout to achieve the 250 million target in next 3 years. And one more thing, that the Government of India is also planning to introduce a new scheme, a 3 trillion Indian rupees scheme, which will provide some funding for the states for the rollout of the smart meter in the country. So out of 3 trillion, 1.5 trillion is estimated for the 250 million smart meters in the country. And also government has also they are also promoting the OPEX model, under which if the states don't have the money for smart metering, then the third party can invest, and then they can recover the money from the discoms on per month basis. Suppose 100 rupees per month basis, or 85, whatever the comes in. So the discoms don't have to invest in advance. Third party will invest, and then they will recover in the next 8 to 10 years based on the rate of recovery. Okay, thank you.
Thank you very much, Mr. Goel. Again, and moving to our last presentation of the day, we're going to welcome Ms. Claudia Gibard. Sorry if I've mispronounced your name. She's a senior policy advisor at the Department of Business, Energy and Industrial Strategy in the UK, and she's also in charge of energy data policy. Will tell us a little bit more about the country's data strategy, which is also a different dimension. We're looking at the way that countries are looking their digitalization strategies. Welcome, Claudia.
Thank you so much. Firstly, thank you for inviting me to talk, and massive apologies for not being on at the right time. My electricity on my street went down, so I'll let that be a useful lesson for us all. System security is very important. So I'm here today to talk to you about our journey towards our digitalisation strategy for our energy sector in the UK. Next slide, please. So the reason why we're digitalising our energy system is really in response to our net zero targets. By decarbonising our energy system, we are having to connect so many new assets onto our system. And doing this creates a huge amount of complexity. There are a lot of challenges, which is that, you know, all of these assets are going to be, you need a lot of data to understand where they are, what they are, where they're connected. And you also need data on the network to understand where the constraints are. And so, although today data is really important for managing the system, this huge amount of change just basically illustrates that with our government targets, with 10 million EVs and 600,000 heat pumps installed by 2028 per year, we are going to need an awful lot of data, much more than we have today. And the success of this transition away from a carbon-driven energy system is really reliant on that. And we don't just see it as a challenge, but we actually see a lot of opportunities from doing this as well. Next slide, please. So just to illustrate how we see data and digitalisation relate to each other, I have an example of two supermarkets. Basically, supermarket W is Walmart and supermarket K is Kmart. We all know Walmart is a really big leading supermarket in America that is in low-cost retail. So both, whereas we don't really know Kmart. So both supermarkets in the 1980s introduced barcode scanners. They saw it as an opportunity, but Walmart realized that there was a lot of data that you could get from these scanners, and they used this to create a really sophisticated logistics system, which eventually led to them being the huge chain that they are today. Whereas Kmart noticed that it was just saw the barcode scanners as a way to reduce having the price of having to change price stickers all the time. So it's really, the difference is having all the gear and no idea, and then Walmart realizing the potential and the value. And that really is the difference between data and digitalization. So we have found it really important to emphasize the value and the usefulness of creating data, but also connecting it to other data sets, because that's where you really drive your value. And this is especially true for the energy sector, because the energy sector sort of sits at a nexus and at a point which feeds into all of the other sectors. If you think about every sector's value chain, ultimately energy will be a part of it. And so it's really important to take this outward looking stance so that you can connect energy data to other data from other sectors. So digitalization of our energy sector will basically provide the necessary information so that we can welcome in new participants into the sector. And so we see digitalization as basically our remedy to shifting a critical national infrastructure and changing it in a really big way. During this time of flux, digitalization is basically your remedy to get over critical national infrastructure risk aversion. And so we see it as a great opportunity to externalize all of this complexity that I talked about at the start and welcome in new participants to optimize it in novel and innovative ways by making sure that we can provide high quality energy data access to all in a safe and secure way. And so digitalization really is a brilliant way of enabling whole system thinking. Next slide, please. So you can understand that we see it as a great opportunity to coordinate a sector to transition, but taking a step back, where are we in the UK? Well, the UK's energy sector is really at the start of their digitalisation journey. We will be publishing our first digitalisation strategy in spring. But when you compare it to other sectors, you can see on this diagram that we really are at the fundamental stages. Next slide, please. So I just wanted to run through the sort of challenges that we've faced when thinking about digitalization. So we have some legacy systems and cultural barriers, which is really referring to the fact that when there's a lot of people who operate in our energy sector, and they're brilliant, clever people, but there's examples of people having to create a cultural shift, especially in our licensed companies. So our network companies, for instance, are very used to engineering solutions, and engineering solutions are a really safe, secure way. And this is referring back to that critical national infrastructure risk aversion point. They're used to creating an engineering solution that will last for decades. And we want to come in here and ask them to use software solutions rather than having to create a new wire, take advantage of a new avenue of flexibility. But that's software solutions basically fail hard and fast. And it's really difficult to get over those kind of barriers because it makes people feel uncomfortable because we've forced the sector to be quite risk averse for many years. The second challenge that we've had is that this is a huge challenge. It's an amazing, exciting opportunity. And so that has actually welcomed in so many different actions and activities. And so we found it really difficult to have oversight of what's happening all of the time. And actually a lot of duplication of work has been happening. And the third barrier is that there's huge interdependencies of change. So I referred already to the fact that energy sits at sort of a severe point of complexity because it touches into all of the other sectors. And that is a really difficult challenge to overcome because every solution that we make, we should do it in collaboration with many other people. And so it makes it really key to have central governance and a strong role for government to make sure that we progress in sort of like an outward looking way rather than creating solutions in silos. Next slide, please. So this is our journey so far. Our strategy, which I mentioned is going to be published in spring, is the next step in quite an exciting journey that we've been on since 2018, where we had a document which published and we identified data as an area that we needed to work upon. And so we set up a Modernising Energy Data Programme, which is comprised of BEIS government, where I sit, Ofgem, our economic regulator, and Innovate UK, who supports research funding and development. We did this because I think it's really important to take a really transparent, collaborative approach to policy making, and especially in this area. And then we sponsored a task force report, which was going to identify how we could modernise our energy data. They produced 5 recommendations, which we formally endorse. Next slide, please. So this report is really what kick-started off our digitalisation journey and galvanised the sector and created a huge amount of momentum. It identified that we needed to create a staged approach to digitalisation because it is such a big issue and huge challenge. You're not going to solve it all at once. And it basically said that we need to ensure that we have data visibility, asset visibility, because it can create optimization opportunities, open markets, and better policy making and agile regulation. Next slide, please. So what were the 5 recommendations? Well, they can basically be seen here on this right-hand side table. The first was that the energy sector should digitalise and adopt a presumed open principle. So we've been doing a few things to make sure that we reach this, which is to make sure network companies create digitalisation strategies and action plans, and also make sure that they have the appropriate guidance in place to support this. The third recommendation was that energy data should be discoverable, searchable, and understandable. And so we've created an energy data catalogue so that people can search for what energy data, exists and is collected. And that is not the same to say they can then see what the data is that is collected. They can't access the data, they can just see what data is already collected. The 4th recommendation is that energy assets that interact with our energy system should be accurately gathered, available as needed and appropriate. And so we have a coordinated asset registration strategy, which is basically making sure that the data that we collect on assets connected to our system is high quality, accurate, and not missing, because at the moment it is a bit like that. So, and our fifth recommendation is that the information on the energy infrastructure should be easily accessible. And so you can see on the left an example of ENA's digital systems map, which they are developing at the moment. Next slide, please. So it's really difficult to convey all of the work that's happening. And so here, this slide shows how we see our work delivering value, So we think about our data in terms of a data value chain. And it starts off with making sure that you have high quality data. We have a few policy interventions I've already mentioned through our coordinated asset registration strategy to ensure that we do actually collect high quality data. And the key thing with this is that whilst we're expecting lots of citizens to participate in this revolution of our energy sector, we need to get a lot of data from their homes. And so that needs to be as unburdensome as possible. Then we make sure that that data that we've collected is visible, and so people have a means to search what data is actually collected through the development of a data catalogue. And then we have this data access, which is ensuring that once they have searched it, they can actually access it in a safe and a secure way. Finally, we make sure that whatever capabilities we are building, we are making sure that we stimulate the market. So we have competitions which are going to build off of these capabilities and sponsor these, and then they actually deliver value and drive home what we are building as we go. And then I really want to emphasize that we always have to review what we are doing next. And so we review what we've done and reprioritize our next steps. Next slide, please. Finally, I just want to very quickly emphasize a few key points I've already made in the presentation, which we found really useful. And that's think about your data value chain, take a collaborative and open approach, and be transparent as you collaborate with the sector, because everyone is learning. And I think that's the best way to do it, so that you're aware of risks that licensed companies have at the beginning. Take a phased approach towards digitalisation is a massive challenge. You won't solve it all at once. And the best way that we've found to prioritise your work and your actions is to think about what your use cases are. And then you can identify a single part of the problem and you can deliver value quickly. Thank you very much.
Thank you very much, Claudia. It's very, very enlightening as well to see the perspective you've taken as well in the UK. I think rather than doing a clarification question, I'll just jump straight into the panel discussions. I'm going to ask all the panelists to activate their video. And maybe like a bit of a curveball, but or I think, well, the panelists from the first session. I think that I also like reading a little bit of the questions that have come up in the side chat. If you've been looking at it, there's been talk about standards, about trust, about defining security platforms, identifying the business cases, and I think oftentimes there's a question of does regulation even move fast enough to catch up with technology? So the question for you would be either why did your governments choose to go for a digitalization strategy and not just leave it to the markets, or alternatively, what was kind of the kickstarter? You said, okay, there's this happening. Now we really need to go for, a digitalization strategy. Like, what was the main driver to plan it ahead, so to speak, or kind of steer it? Anyone wanna?
I'm happy to very quickly start it off. I think that for us, the way we see it is this is coming whether we like it or not. And it's better to be ahead of the curve. We're already behind the curve, probably. I mean, policy is naturally always a bit behind the curve. It's reactive in its nature in a way. But it's best to go along with the sector whilst they're learning about it, so that you can be live to the issues and notice the risks as they evolve, rather than come to the table a bit late, has been our approach.
Anyone else? Like Carla?
Okay, I guess as I was mentioning in our presentation, we already learned that we have to, there is a role to play by regulation by the state. And we need actually to somehow collaborate and coordinate with the markets, because it doesn't go in the direction we want to go of decarbonization and decentralization, as I mentioned. So in our case, we are as Claudia said, we are also a little bit behind already, but I think it's a must to go faster, because we want to take the advantages of digitalization as quicker as possible. So I guess in order to maximize the benefits of it, I think we have to move faster.
I would also add that I think digitalization creates a great opportunity to have better policy and regulation. No matter what happens, if you have better data in a more timely fashion, then you could move towards more sort of monitoring approach to regulation, where, for example, digitalization might make it so you can live review trust pilots and identify problems that way. And it's a really great opportunity to be much better and quicker and responsive.
So I think, sorry, do you like to start here, Mr. Mishra?
Okay, go ahead.
Okay, thank you. I think the situation in Germany is very much driven by a certain culture that is very much influenced by concerns of security, of supply. And so the process of digitalizing the energy transition in Germany was very much driven in the beginning by the perspective of the regulators and the grid operators. And right now we are in a very interesting learning process that we are discussing new approaches to the gateway. I think I answered a question here as well in this direction. We are considering allowing to open a secondary channel that is not on a unique communication line, but also part of the internet. So what I'm trying to say here is right now, this whole process of digitalizing the energy transition in Germany is also incentivizing a new way of dialogue between the market and the regulators. And this is, it was really a very problematic process in the beginning, but now it's getting pace, and it's yeah, we already see what is actually possible here in Germany by taking digitalization as an opportunity, but not only as something that has to be in bay or controlled, and that is something we learn right now.
Here in India, also the initial focus was operation driven for the network, and of course that gave us confidence to target higher, aim for one nation, one grid. So once we had that in place, there were experiments right through 10 to 15 where the regulators, policymakers, they learned that connection, digitalization, and of course the visibility gives you possibility for flexing some of the value which otherwise is locked up because of the decisions being in months or years versus decision you can take in weeks or for that matter days and hours basis. So having done that, the policymakers wanted to discover whether there exists a case, and of course there was worldwide trend on the smart grid, there exists a case for doing something on distribution side. And the experience in first 3 years with those pilots was very positive. What can be achieved, some of the pain points of AT&C losses, some of the pain points of not knowing And I mean, even to asset operators, some of the discovery was eye-opening. So they were really hungry for it. But yes, there remains those uncertainty and fear of technology, interoperability, lock-in. So the uptake was not en masse, or it isn't en masse. So that is where regulator thought of, okay, let's if we can have a 5 or 7 years of place where market players bring the technology, and they also create value for everyone to be shared, and they get from that value, so that everyone will get mature and we'll have a much better situation. So that's where pay as you say model came in. There are players, and we got now 20 million, more than 10 million smart meters going on. And that's where my units comes in. We are trying to do some pilots, get more value for the utilities, and if that discovers unlocks, I'm sure there will be floodgates of digitalization will be open across the distribution sector. But yes, we need to learn the consumer preferences, and where consumer sees the value versus what utility seeing the value, or for that matter policymaker seeing the value today is, yes, you can enforce more discipline upon the operator as far as consumer rights and consumer um, or equal opportunity is concerned. So that's all those things are playing in, and it's really an exciting time for the asset owners and the digital um, team, which otherwise is, India is famous for IT skills and back office of the world. So the entire industry is again very excited participating in this evolving phenomena.
Great, thank you very much. Alejandro, do you have any remarks, or we can move to the next question? So one thing I really like as well about the presentation is, like, usually I find digitalization discussions center a lot on the hardware, as you say, what technology you want. And I think a lot of them were kind of more focused on the use case and on the ecosystem that you want to enable. Particularly, speaking of, concerns about security and what faces the end consumer. The discussion tends to focus on, smart meters, and if we don't have smart tariffs, then we're not going to do anything. What are other key areas or key benefits of digitalization or effective data use that you identified that go beyond, say, the picture of me going to the wall, looking at the price, and saying I'm not going to turn on my washing machine now? Like, what are other benefits of digitalization that you've identified through your programs?
For us, I can start with that. For us, it's an opportunity, as Claudia and Matthias were saying. It's an opportunity to make better policy, but also to target better security and reliability of the system. So we want to we see this as an opportunity to, for example, recover services when they go down more quickly, identify failures quicker also. And so we see on that side a great opportunity for more reliability and security for the system, and for people, for restoring their services, but also to monitor equality in that sense, since access to energy and the quality of access to energy has to do with equality and equity for people in terms of access to energy. So we see these technologies as an opportunity for making better policies overall.
I think in Germany, a very important aspect is also, of course, not access to energy, but access to the energy markets. I mean, you described the situation of the end consumer. You mentioned this washing machine example, but I think this is related maybe to the bigger picture, to enable smaller stakeholders like prosumers or the flexumers to be part not only on local markets, but also in the end, if it's possible from a technological side, but also enabled from a regulatory side, to take part in all available energy markets according to the opportunities. And I think this is also a huge contribution that digitalization can actually give. Yeah, and of course, I have to add the security aspect is very important here. Also, the whole aspect of predictive maintenance and maintenance of grid infrastructure by using drones, by using image recognition is something that it's kind of news to me. I was not used to work with such topics, but I kind of grow in those topics. It's really it's really important when it comes to allocation of resources for grid maintenance and all of that. I think this is really important as well.
Actually, there may not be the one solution for all the countries. As far as the installation of the smart meter in India, we see that because as we know that we don't have the data flow, we don't have the digitization at the distribution level, and through smart metering we will have the access to the data. So firstly, in India, we are seeing the financial benefits to the distribution companies, because we know the distribution companies are in the losses, and in India we have the aggregate technical and commercial losses around 20%, 20 to 21%. So firstly, whatever the use cases we have used, so we have seen that so we can reduce these losses, so that the financial positions of the distribution companies can be improved through the use of smart meter. And these we have proved with some pilot projects and some use cases also. And their investment has been recovered within 3 to 4 years if they reduce the AT&C losses from 20% to the 12% or the 11%. Then they can recover the money within the 3 to 4 years, and then afterward they can have the profit from this. So because in India we have the two-part tariff, one is the fixed tariff and one is the variable tariff. So fixed tariff, if you have the connection, suppose 1 kilowatt hour, 1 kilowatt maximum demand connection, and you are actually consuming 4 kilowatts. So earlier we don't know through the electronic meter or through the electromechanical meter. Now we can have the actual the maximum demand with the consumer is consuming, and then we can have the actual tariff which the consumer has to pay. And then so this is the one of the big factor for India. And another is the consumer empowerment, so that the consumer can see their demand on daily basis, whatever I have consumed yesterday, whatever I am consuming, so that he can adjust its demand according to its requirement or something. And another angle, India is seeing the integration of the solar rooftop. So India is going a big way in the solar rooftop. So integration of renewable energy through net metering. So smart metering, through net metering, we are also promoting. So smart meter will work as a net meter also, and the consumer can install the solar rooftop on their solar plant on their rooftop, and then they can enjoy the net metering profits. And another is now India is looking for the EV integration also. Thank you.
Thank you very much. Mr. Misra or Claudia?
Yeah, I would be happy to say list off lots of things, and there are other benefits to digitalization, but I think it even does it injustice, because really you don't actually know all of the possible amazing things that could happen. I think it will lead to a huge boom in possibility in connecting all of these different things together. But to list off a few, it will create better services and more enhanced price signals so that people can prosper from this transition. It will enable new market entrants to enter into the market, as mentioned by the other speakers. You're going to be able to make sure that you have vector interoperability if you bring on hydrogen or heat networks. It will support that transition, and like we said, better policy and regulation you'll be able to identify new optimization opportunities, for example, taking advantage of supermarket fridges to optimize the system. And you could end up with things like self-heal grids or automatic local trading. But again, like I say, I'm going to return to the point, the opportunities are endless, and we won't know until we get there. But that's a few.
Enrique, if I may, and I just to echo Claudia's message, I think the digitalization agenda is quite complex in the sense that we know that we need certain policies to provide basic frameworks, and there are many coordination problems in the industry on the standards and how privacy is to be handled, etc. So at that stage, of course, we need a strong policy direction. But at the same time, we require from the participants to come up with the innovation. Like at the end, what we want is this an enabling technology, and we need the retailers, consumers, industrial, etc., for them to come up with the solutions to very specific problems. And it's certainly is not only the power system problems that are to be solved. One example that I really liked in Japan, after just a couple of years of having opened the markets, there were already retailers using the smart metering infrastructure to propose other kind of services, which were, for instance, if you wanted to check if your house, if the lights were on or not when they were supposed, because you have maybe the kids at home, you have an elder that you would like to be taken care of, etc. So it would provide basically a message to your mobile phone saying, your lights are on or your lights are off when they were not supposed to. So there is this kind of, and this could be very valuable, right, for people. So it's beyond. I think this is one of these kind of nice things of digitalization, that it goes beyond the power sector. It's finding smart ways of finding all this information and to use in a smart ways.
So I would like to add something that is also related to the question here in the Q&A section. That is the question, what could be the role of the DSOs in the near future? And what we have to discuss also is, I think, the role of digital and physical infrastructure and kind of the trade-off between both. As I mentioned, in Germany, the reasons why we went this very, kind of over-engineered approach with the smart meter gateway is also to use flexibility in order to avoid grid expansion. And I think in this trade-off situation, the DSOs will play a very important role in the future, and they already do.
Yeah, exactly. And I think unless Mr. Mishra has any final remarks, because we are running out of time, I think these are all very good points. Mr. Mishra, do you have any final remarks, or we move on to the next session?
I think the TSO part is very well captured by Matthias. And the moment you start getting value from operational shift, DSOs will be the key for realizing and managing the system. Yeah.
Okay. Thank you very much. So keeping in mind the idea of I would say, the wonderful unknowns and where's the limit, I think we're going to move on to the wonderful knowns and speak about technology and what's already happening on the ground in different countries. For that, I'd like to welcome my colleague Vida Rosita from the IA as well to start the second session and introduce us to the panelists speaking about technology opportunities. Thank you very much all, and speak to you soon.
Thank you. Bye.
Thank you.
Once again, thank you to all our speakers for this really exciting and an inspiring session. As we heard, it is an exciting time and the opportunities are endless. My name is Vida Rosita. I'm from the International Energy Agency. I'm leading our work on digitalization, including the Digital Demand-Driven Electricity Networks 3DEN initiative. And it's a great pleasure to have the opportunity to moderate this session on getting down to business. We have a fabulous lineup of speakers for the session. And let's start with Amro. So Amro from Dartmouth College. Amro, I'm still reading your book. It's taking me a long time because every time I turn a page, there's a new concept, there's a new opportunity, there's a new challenge. And it really very effectively conveys how we are at a brink of an utter transformation of the energy system. So Amro, please tell us more.
Can everyone hear me okay?
Yes.
Okay. Let me request remote control. And is also my video visible at this point?
Yes.
Oh, good. Wonderful. So let me now try to advance our slides. Okay, so I'll be talking to you today about unlocking the shared integrated grid from diving ducks to digitalization. So my goal today is to describe a way forward for unlocking the shared integrated grid rather than building or creating. And you'll see what I mean as I go forward. And really that has several different aspects to it. Following the diving duck, empowering American communities, embracing dynamic data-driven markets in about 14 minutes or so. And I'm going to leave you with my bottom line up front, that activating the grid's periphery is very much tied to activating local communities. If you want to move the grid, then you really have to think about moving the communities at the grid's periphery. So several years ago, I did my lab, that is, did the renewable energy integration study for ISO New England in 2017. And they had us look at a wide variety of different types of renewable energy integration scenarios. One of them here, what we call the 2025 conventional or business as usual case, very much features the proverbial duck curve that California ISO had coined that term in 2014. So we see that the thermal plants have to ramp up very quickly in the evening. This is a week-long description of the real-time energy markets. And so the duck curve here is very much alive and well. But what's interesting is the high renewables scenario. So now solar and wind in magenta and pink really begin to take over in terms of much of the variability of the load shape. And I call this the duck dive curve, because where we saw the duck before, the head of the duck now in these scenarios is very much going underwater into the base load. And so sometimes the head of the duck appears partially, sometimes it's entirely submerged. And what that means is that there is the traditional generation fleet must be ramping quite a bit over the course of the day. And so we have to be ready to be able to enable that with all sorts of different types of grid flexibility. So shortly thereafter, the Department of Energy asked us to do a follow-on study, what we call the New England Energy Water Nexus study, where they asked us, well, okay, can we get that flexibility from energy water resources of different types? And of course, water appears in lots of different places in our energy system, from hydro plants, but also very much on the demand side. So here you can imagine using water utilities and the flexibility that they might be able to bring to bear, wastewater utilities, but also water heaters that are in our homes as well. And so we penetrated that flexibility by 5% across 6 different scenarios. And what we found was synergistic benefits across the board in reliability, in environmental performance, and economic performance. So with regards to balancing performance, we saw not just greater flexibility, but also reduction in the curtailment that is required, as well as a reduction of the grid imbalances as well. The need for the use of water and the consumption of water as well, because the traditional thermal fleet, of course, does both withdraw and consume water. And then because it allows greater renewable integration as well, CO2 emissions come down for whatever the fleet that you have. And then what this also does is it provides a greater space for finding optimal solutions. And so you can reduce the production costs in both the day ahead and the real-time markets. So the question is, where am I going to get that flexibility from? And the answer is from the periphery of the grid. So on the left, we have a nice way of representing our conventional grid with a mesh transmission system, a radial distribution system, and consumers out on the periphery. And so now we can imagine that the grid's architecture will evolve to include the green circles, that would be distributed generation, the two-way blue arrows, that would be flexible loads, and the potential for greater meshing in the distribution system through microgrids. What's really important to keep in mind is that the grid's periphery, you're going to need these, what we call energy Internet of Things, that are network enabled to be able to provide that flexibility in order to realize this type of vision. So what is the energy Internet of Things? Well, it's really quite ubiquitous. You can imagine all sorts of different types of devices, whether they are water heaters or appliances or stoves or so forth, that are network enabled and potentially connected to your phone as well. They are going to be connected through multiple different types of networks, as some of our colleagues have already explained earlier today, whether they're local area networks, neighborhood area networks, or wide area networks. And I encourage you to have a look at our EIoT book that came out a couple of years ago. This is open access and available to the public. So, just search for it online and you'll be able to find it. And it gives a very good description of how the sustainable energy transition and the EIoT, when they collide, can actually support and enhance each other rather than otherwise. So once you start really thinking about the energy Internet of Things, what you begin to do is think about a shared integrated grid. And it's not just about devices, it's about really two other things that you have to recognize, that these devices are consumer devices. And so really, if you want to engage the devices, you really must also engage the customers as well. And then once you have engaged the customers, you really want to try to get the benefits from the customers and from these devices. And so that means you're going to need community level coordination, which brings me to the central message of my talk, that activating the grid's periphery means activating local communities. So how far along are we in the United States to go being able to do that? And the answer, particularly to an international audience, is that the United States is a remarkably heterogeneous regulatory landscape. It's not necessarily easy to understand, and the literature on this is quite scant, but the DOE did put together they commissioned a study by E9 Insight that looked at all of the evolving regulatory structures that are happening at the state level. And it was an excellent report. If anyone's interested, I can share it with you. And what they did was they tried to develop a periodic table, if you will, of different regulatory structures. And what you find is actually something really quite interesting. Up here towards the top right, you see larger states that have the ability to really innovate and look at things very deeply. You also see that they have much larger markets And of course, you might have heard of the various initiatives from California and California ISO to enable greater distributed energy resources. There is New York Rev, but there are other states as well that are following suit. Texas, of course, is one of the most deregulated states in the country that has also been in the news as of late as well. On the other side is really states that have focused more on the vertical integration type of approach, more conservative in nature. And so really this is a tale of two grids. And I highlight a quote from the report. It says, on the one hand, there are states where the policy is moving towards more open market solutions, including community ownership, community choice models, and auction mechanisms. On the other, there are states that are more inclined towards expanding vertical integration models and sort of doubling down on monopolistic behavior. And just for a little bit of context, each of these different elements of state policy can be looked at from a total revenue, how much is the large utility revenue, how much is investor owned, so forth, so on. And then also the governor state house, is it, Republican, Democrat, and then the number of commissioners. So they provided a really interesting way to create a taxonomy of the different regulatory structures that we find in the United States. So this is taking a while to advance the next slide. But really what you need to be thinking is imagine a world where customers are part of the solution rather than kind of an afterthought. And so I've been working with the Electric Power Research Institute for several years now, and together we call this the shared integrated grid. So what might that shared integrated grid look like? Well, one of the really interesting advancements in regulatory structures is community choice aggregators, or sometimes called community power aggregators. And what these policy instruments allow for is for communities to form aggregators that will now provide different types of electricity rates and services to their various communities. Thus far, about 750 CCAs have popped up across the country, led first by tier 1, followed by tier 2, and there's also quite a bit of restructuring in tier 3. They serve about 1,000 communities. To give you an idea, there are currently about 3,000 utilities in the United States. There are 750 CCAs, and there are about 19,000 different cities, villages, and cities in the United States as well. So there is an opportunity for proliferating this type of regulatory structure. So how might it work? So the conventional model, I think many of us are familiar with, where you have your supply chain of generation, transmission, distribution, and the consumer. You also have, of course, the generation company, the wholesale market, and the utility, and the consumer interacts directly with the utility. On the community power aggregator model, what you now introduce is a municipal aggregator that could potentially provide a lot of different services. Here in New Hampshire, and I'll get to that in a minute, the municipal aggregator, once it's formed, will become the opt-out or default provider of electricity rather than an opt-in provider. And the municipal aggregator can provide a number of different services, from fixed tariffs to real-time pricing and really everything in between, and they're allowed to innovate. And we'll get to transactive energy in a moment. So in New Hampshire, in 2019, Governor Sununu, who was a Republican, signed Senate Bill 284 on community power aggregation, and it became the RSA 53E statute. And various communities across the state have been working together to form what is now called the Community Power Coalition of New Hampshire. And it draws from a broad spectrum of different stakeholders and towns and counties. They make up about 10% of the revenue now. It's one of the things that I have been, working on supporting in an advisory capacity. And one of the things that they also can do is that it doesn't have to be individual towns, but they can also form joint power agreements, as is done in California. And the one here has been approved by the State Attorney General. I'm advancing the slide. So another thing that has happened along the way, very much in the same vein, is that here at the Dartmouth Laboratory for Intelligent Integrated Networks of Engineering Systems, the LINES, we've been developing a real-time pricing transactive energy service prototype for the city of Lebanon, which has been an integral part, and if not leading, the community power aggregation. And we worked with the city of Lebanon and Liberty Utilities to develop this transactive energy service market prototype, which would involve a basically peer-to-peer type of market design that would allow for real-time pricing to happen within the context of a community power aggregator. And then the last thing I want to say is that while also the community power was being signed very shortly thereafter, also in 2019, Governor Sununu signed Senate Bill 286 on a statewide multi-use energy data platform. Data sharing is a prerequisite to a shared integrated grid. And for the economists in the room, we all know that the availability of data and information is very important to fluid and active markets. And so there has been a PUC proceeding on how to design an energy data platform in New Hampshire. It's still very much going on, and like all proceedings, there's a lot of debate and healthy discussion. It involves, and we can imagine that such a data platform would have data coming back and forth from potentially distribution companies, curtailment service providers, third parties, load serving entities, consumers, prosumers, potentially academia and other governmental agencies. And the question, of course, is how do you design it and build it? A question that I often pose to my students. So my last slide, oops, we passed by my last slide. It managed to have disappeared. So that's fine. So thank you very much for your attention. If we want to activate the grid periphery, we must, of course, activate our populations in a shared integrated grid. Thank you.
Thanks so much, Amro, for sharing these insights and stimulating examples. Also, for all the listeners, we did have an outstanding question from Amro, so please do use the chat function. And do have a look at Amro's book, very interesting, and as he mentioned, open source. I'd like to now introduce Alexandra Radwanska from Next Kraftwerke. Alexandra will talk to us about digitalization and system integration, and give us some perspectives on opportunities for renewables, trading, virtual power plants, and decentralization. Alexandra, the floor is yours.
Thank you very much. Thank you also to International Energy Agency for inviting us to this very interesting event. My name is Alexandra Radwanska. I'm International Business Development Manager at Next Kraftwerke. And at the beginning of my presentation, I'll very briefly introduce to you this company. So what we do and who we are. So Next Kraftwerke operates since 11 years already, a virtual power plant of almost 10 gigawatt of installed capacity, currently aggregating over 10,000 of energy generators, energy consumers, and storage units. Our company is present in 8 European countries, where we trade electricity from renewables and provide ancillary services to the system operators. However, I would like to highlight that we do not own any electricity generating unit. And in fact, all power plants that we manage are in possession of our clients, who are independent power producers who say someday decided to invest in a hydropower plant or an anaerobic digestion facility or a big PV farm, for example. But they wish to outsource the activity of commercialization of electricity to some broker or trader. So since virtual power plant has become a buzzword recently, I would like to make sure that we have the same definitions and we have the same understanding of this technology. So the setup we work with at Nextraverke is a virtual power plant defined as network of decentralized energy generation units such as wind farms, solar parks, CHPs, and so on. And these units are connected with a central system that controls their generation. So that means that our goal is not to operate, for example, as a microgrid to provide autarky or self-sustainability to the consumers in our portfolio. Neither we are trying to directly match the generation, say, of one unit with the consumption of another one. So, of course, this virtual power plant intelligently controls generating units, storage, flexible loads, but not in one neighborhood or in one region, but cooperates with the system as a whole. One may ask, so where's this intelligence? Where's the added value? Everyone can trade electricity from a portfolio of renewable generators, and they will be quite right. Because the added value of virtual power plant is not the delivery of electricity, but it is the flexibility of these decentralized energy sources that we unlock and sell on a power exchange, for example, on the wholesale market or on the balancing market to the system operator, which means that we sell an ability to instantaneously, very rapidly change electricity generation or consumption in response to an external signal. And this external signal can be, for example, a price signal, but it can also be an activation from the system operator that asks us to provide a service of stabilization of the frequency, for instance. However, we need to remember that this flexibility, which of course is enabled by the digital tools, can only be considered beneficial and create another value when embedded in proper market environment. So on the next slide, I gathered only a few, but in my opinion, very important conditions promoting digitalization and flexibility of the energy system. The central question that we always ask ourselves at Next is, when analyzing different markets, right? Is this market really in need of flexibility? Is this market really willing to buy it, and for what price? So to grasp better the factors promoting digitalization, it is also quite helpful to have a look at how our business developed in Europe. So in fact, the trigger to this development was a very rapid growth of renewables that started causing problems in the balancing of the entire electrical grid. So the regulator started to then look for applicable market rules that would incentivize, usually financially, the traders and electricity producers to proactively keep balance in the grid. So for example, such mechanisms are, say, introduction of hourly or even quarterly changing electricity prices, and making sure that renewables, and in fact all generators, are impacted by their fluctuations. To ensure it, then the feed-in tariffs offering fixed price for each megawatt hour were changed into, for example, feed-in premium mechanisms, which mobilize renewables to change their generation schedules according to different price signals. Then renewable generators started to be held accountable for the imbalance that they cause, which also increased the need for very precise forecasting on the day ahead and intraday basis. As a result of rapid growth of renewable generation, some markets also started to experience negative prices for electricity. And this was yet another mechanism that was encouraging flexibility in the form of, for example, price arbitrage or curtailment of renewables. Additionally, in fact, Germany and Austria, so I'm speaking on the example of countries where Nextraverke is present, were in fact at the forefront of allowing small distributed generators to deliver services helping transmission system operators keep frequency at 50 hertz, and in fact, to earn on this operation, right, to make business on it. So this opening door opened the completely new category of business cases for renewable generators, but also at the same time, it was ensuring for the flexibility and security of the system. So in fact, to be able to adopt all of these tightening rules, technology providers as Next and energy companies also as Next needed to use some more and more advanced digital tools and technologies. For instance, the Next-Kraftwerk has virtual power plant, and in fact, the VPP as a service, which we also offer to other energy companies, helps them and us to monitor in real time and very precisely forecast renewable generation. The portfolio managers are also able to control power plants, and I mean here individually, but also the whole pool at the same time. Additionally, by this mechanism, we support business cases that want to use price arbitrage, or for example, would like to curtail renewables. Additionally, in fact, one out of quite a few companies, we work within an infrastructure that is so reliable that it can enable decentralized renewables to also provide instantaneous balancing services. And by instantaneous, I really mean the products that are activated within 5 minutes or 30 seconds. However, the technology choice, which I describe here, was just a consequence of the regulation and the market mechanisms that aimed in the first line, in fact, to really ensure security and reliability of the system and its stability, even with the variable renewables on board. So at the end of my presentation, I would like to leave you with one thought, that the digitalization is beneficial and it really can create another value, though we must remember that it does not constitute a value on its own, because big data, AI, machine learning, the most advanced algorithms will not generate clean electricity and will not ensure system stability out of thin air. And these technologies only make existing potentials easier for people to grasp, to analyze, and thus better utilize. And with this, I really thank you for your attention, and I'm looking forward to the panel discussion. Thank you very much.
Thank you so much, Alexandra, for this really inspiring presentation. I particularly liked the slide where about asking the right question at the right time. And let's move on now to John Finney, who's from Hitachi ABB Power Grids. John will tell us a bit about the opportunities in terms of digitalization that he's been encountering, but also will talk to us around the prerequisites that are needed to take advantage of these opportunities. So thanks so much, John. The floor is yours.
Thanks so much. Hi, everybody. I'm John Finney, joining you here today from just outside of Zurich, Switzerland. And let's see if I can get the page down to work. There we go. I hit it 3 times, so we'll see if by like Moses, I go halfway through the presentation here. So just to remind you who we are. So Hitachi ABB Power Grids is a joint venture between Hitachi and ABB. So as Power Grids, we have a 100-year history of helping utilities, industry, and transportation in their journey to electrify and participate in this important sustainability drive that sees a significant increase in renewables and a drive toward digitalization that allows us to help achieve that vision. Okay, so we've spent quite a lot of time with our customers trying to identify, what are the challenges that they face, largely caused by or participating in the transformation of the energy sector, right? With a drive toward increased electrification and a drive toward increased renewables at the same time. And so the challenges that we see, of course, are increased system complexity driven by taking advantage of a flexible integration of everything from central generation all the way down to grid edge participation. We also see at the same time, however, an increase in unpredictability and reduced reliability put in place by from two main aspects. One, of course, is that renewable generation is outstanding, but it is not nearly as controllable as the sources that came before it. At the same time, both end user customers, grid operators, and asset owners have financial expectations on their own and as corporate entities, and so driving on cost. The good news is that digitalization, which is not just, as was said earlier, digitization, but using the data in creative ways, helps us in almost all of these areas, right? So application of everything from machine learning to advanced algorithms, increases in security technology, increases ability to perform, use data, connect data between different parts of the grid in multiple ways are allowing us to address and solve these problems. And what I'm going to do in the next 3 slides is I'm going to give you 3 examples from completely different parts of the value chain where we have worked with customers to use digitalization for the impact of helping them increase system reliability, integrate with renewables, and at the same time, importantly, reduce costs and achieve their financial objectives. Okay, so the first thing that I want to remind you of is the importance of the substation, right? For power engineers, you know this already. For the rest of you, a substation are the nexus switching points that operators use to steer power through the grid for maximum reliability. And they are the backbone of the electric power infrastructure. For about 20 years ago, we saw a revolution in the industry, which saw the standardization of a bunch of proprietary practices onto a new standard called IEC 61850. And 61850 has become almost a best friend to those of us in the industry, because much more than just a communication standard, 61850 is an engineering standard that carefully balances the ability to increase cost effectiveness of design, reduce the cost of replicated design, reduce training, increase testing capabilities at the same time. Now, when taken to its full digitalization benefits, using a standard like 61850 really allows several things to occur for our customers at the same time. The first is maximal use of the data coming from the substation in the substation and back to the control center allows for better, more cost-effective protection, which increases the reliability of the grid. Importantly, however, by switching to the new technology, it's also possible to get much smaller substations, which of course is less costly. And finally, when it comes time to upgrade a substation from the old technology to the new technology, the amount of time that the substation is out of service is significantly reduced. So all of this around the world is seeing really great benefits, and we're very happy to be participating among all the major vendors in the world as we in the transformation to digital substations. The second example I'm going to give you is one that shows the importance of machine learning. So our infrastructure in the grid and in the generation facilities is aging. And we are participating as an industry in following from what started out in the aerospace industry of using condition monitoring and prognostics to be able to forecast the imminent failure of devices that are inside of the electric power system. Okay, so what does this mean? This means that our customers then have the ability to stress their assets further to reduce the amount of maintenance that they do on their assets, prioritize the maintenance spending that they have, but extremely important with these technologies are able to head off and identify what would otherwise be catastrophic failures of major assets and take corrective action to reduce the amount of interruption that our customers see in the operation of their grid. Finally, the last example that I want to discuss touches back on some points that we had earlier. One of the attendees in the chat session was pointing out the need about half an hour ago, the need for when you put in a smart metering infrastructure, the importance of having a multi-service network for communications. And this is a trend that we see around the globe, which is that electric utilities are needing to find a way when they operate their electricity grids to be able to have an extremely robust, high performance, wide area communication system, but at the same time want to be able to leverage a multi-service environment so that they'll be able to accommodate multiple use cases associated not only with protection and control, but also with energy commerce at the same time. The advantage of digitalization in the electric supply industry is we're able to benefit from advances that occurred a half decade ago in enterprise communications, harden them a bit, and make them particularly germane and applicable for protection, control, monitoring, and economic interchange on the electric bulk supply network. Now, one of the keys here and the cautionary note that was mentioned in an earlier presentation is cybersecurity, right? So when we adopt modern digitalization and digitization technologies, we do expose, if we're not careful, a threat vector for bad actors to try to take control of our electric supply network. And this is an area where we've been particularly robust in our application of new technologies such as system-wide wire speed encryption, so that we can help our customers have a defense in-depth security infrastructure so as to minimize the security threat, and as an industry behave in a responsible fashion while meeting the challenges of putting in place some of these digital technologies. Okay, and with that, I know that was brief, but I think I got us back on time. And I thank you very much for the opportunity to speak today, and I look very much forward to the questions in the panel session.
Thanks so much, John, and thanks for speeding things up for us. Just a quick question for you. You mentioned the IEC standard for substations and the benefits surrounding that. Do you have any further thoughts on what's needed to further speed up the development of international standards and promote the uptake of these standards?
Yeah, I would say one of the things that as an industry we underestimated a bit when we started on this journey 15 or 20 years ago is the importance of continuing education, right? Because much of the knowledge of how to operate these networks is in the intuition of the very senior engineers. And with these new technologies, they are very flexible and accommodating toward digital natives. But for any one entity that's wanting to undergo a transformation from one way of doing things to a new way, it's very important that everything from design practices, maintenance practices, operation practices be very well studied and documented. And there are several utilities around the globe that have done a really nice job of piloting that and have provided good examples that can be copied with pride by customers around the globe. So I would say that continuing education is an extremely previously undervalued component of accelerating the digitalization journey.
Excellent. Thanks so much, John. Now moving on, let's go to Yvonne Ruwaida from Vattenfall Distribution. So Yvonne has a really exciting presentation for us. We'll be able to get some insights into regional flexibility markets in action. So the floor is yours, Yvonne.
Thank you. Hello, everybody. I'm joining from Stockholm, Sweden. And my name is Yvonne Ruwaida, and I'm working at Vattenfall Distribution, a big regional and local DSO in Sweden. Next page. And Vattenfall is a part of distribution, a part of Vattenfall, who's a leading European energy company and who has the goal to make fossil-free living possible within 1 generation. Next page. I'm starting with some short facts about Swedish energy system because they are relevant to the demonstrations I'm going to talk about. Sweden has 4 electricity trading areas, and they are connected to trading areas in other countries. And we export a lot of electricity, and Swedish TSO also maintains balancing energy market together with the other Nordic transmission system operators. And the TSOs and the DSOs in Sweden are unbundled from other energy actors. So we are very market orientated with functioning markets for balancing and electricity. Next page. We have a big challenge, and this is why we have these large scale and real demonstrations. We have a second electrification wave with demand for electricity is growing a lot. At the same time, capacity is lower because you have a lot of installed wind capacity. And we have a big transmission of electricity between different trade zones in Sweden. And also the existing networks on the TSO level are very old and they need to be reinvested. And during that time, also capacity is lower than normal. And the rebuilding of the grid on the TSO level will take up to 20 years. So the situation in Sweden is that we actually have had problems in connecting customers on the local level because of capacity constraints on the higher level. Next page. So in Sweden, we have 3 levels. We have the local DSOs, we have the regional DSOs, and we have the TSO. And we have something that's a little bit unique, but we actually have subscription between the local DSO and the regional DSO, and a subscription between the regional DSO and the TSO. And the DSOs, they can be denied to go over the subscription level, or we can get what you call temporary subscription, and then it will have a cost when we are going over the subscription level. It's a cost, a weekly cost, a very low one, like an insurance, but also cost per megawatt hour. And what we are doing in this flexibility markets is that we are working with the grid state forecast. That's also new. We haven't had that before. That makes it possible for DSOs to call for flexibility day ahead. So working proactively to alleviate grid congestion. And in Sweden, I just want to mention that our grid congestion has a very strong correlation with temperature. So we have it when it's very cold. These congestions that I'm talking about now is an issue during only the winter season. And it can be around from 0 hours until 500 hours during the season. So they vary a lot. So this is the capacity challenge. Next page. So we started first the Coordinate project, and it's together with other countries. Spain and Greece also have demonstrations. Our is large scale in 4 areas in Sweden, in Uppsala, in Skåne, in Gotland, and in the north of Sweden, we're also testing peer-to-peer market. 2 big DSOs are participating, a lot of smaller DSOs, but also the TSO. And then you have Stockholm Flex in the capital of Stockholm, and there you have 2 regional DSOs, and you also have the TSO participating. And in this area, we are also swapping subscriptions. So one regional DSO can switch subscription with another regional DSO. This is also a part of the market. Next page. Just to give an example, we have in Uppsala, in Coordinate, we started already last winter. So it's the 2nd winter we have been having a flexibility market. We have a lot of different resources, 2 industries participating with heating pumps. We have hospital participating with reserve gensets. We have Sweden's biggest battery storage, 20 megawatt hours. We have district heating company participating with water boiling and heating pumps. We did have hydropower participating, but they're not participating anymore. And then we also have aggregated commercial and residential buildings who are aggregated. So they are hundreds and hundreds of smaller villas, but also several bigger buildings. And this is just showing the variety of the actors participating. Many of these actors can only participate day ahead because they have to plan their operation. And some of them would want to prefer to participate more intraday. In Stockholm Flex, we also have new other actors participating, like greenhouse buildings and also some chargers. Next page. And here's some market data, because this is for real and we are paying for real. And I can say much about the market data, but we have different business cases in the different areas, depending on the grid state. And we are buying flexibility when we have a risk for congestion or when we're having congestion. So we are mostly working with the product buying day ahead, but we're also buying intraday. I wouldn't say that the prices are mature yet, but it's an example of how the prices can differentiate. Next page. We have a time coordination that's very important, that we are not wanting to interfere with the other markets I talked about before. So we are doing it before the wholesale market, and we're doing it day ahead and intraday. And this is very important and has been very successful. So not to disturb the existing markets is very important. Next page. You can take the next page too, because I see my time is running. The lead time for becoming a flexibility service provider has been varying between weeks until years almost, depending on the type of flexibility resource. And the business case for the flexibility service providers must as well be predictable as covering their expenses. But money enough is actually not enough to attract FSPs. Like you see on the right side, issues like learning, climate, having an efficient energy system, good PR are, I would say, very important drivers. When you work with local flexibility markets, it's very important to have bidding functions, a set time, maximum delivery time, block bid and recovery time for the efficient use of the flexibility resource. And it's very, very important to have standards for communication and power of attorney. And now I didn't make my presentation about data and how we use data, but I think you would see it. It's very, very exciting because we are using data in a way we never did before. This is very holistic. We have been building a data hub with a lot of information that we never, ever have had on the same place ever. And this has made it possible to have this flexibility market. Otherwise, it wouldn't be possible. It's also, it's information from the FSPs, of course, from the significant grid users.
Questo hai capito bene?
From different DSOs and TSOs. And it's really using data in a digitalized way. Even if it's a first step, it could even improve in the future. We have a lot of information on the next slide and links that you can read more. And I hope it will be sent out to everybody. Thank you very much.
Thank you so much, Yvonne. Yes, the presentations will be shared, and I'll take you up on your offer. Next time we'll get you presenting on data. Very much looking forward to hear more about those aspects. Let's move on. We're running a bit short of time. Let's move on to David Sykes from Octopus Energy. His presentation title is The Conservative Data Analytics and Automated Solutions for Residential Customers. But I have had a sneak peek, and I know that one of his slides is about unleashing the Kraken. So I'm looking forward to another exciting presentation. Please, David.
Thank you, Vila. I can't start my video. I don't know if that's
That's fine. We'll imagine how you look.
Okay, exactly, perfect. And I'll try and be quick so we can get on to the juicy questions. So thank you for having me, and amazing presentation so far. My name is David Sykes. I work for Octopus Energy. Very briefly about us. So we started in 2016. We started as an energy retailer in the UK. In the 5 years since we started, we've grown to about 2 million customers, and we've started retailers in Germany, Australia, US, and have projects in New Zealand and Japan. And I think crucially, our mission is really defined as engaging customers in the energy transition, and I'll talk about why that's super important, and doing it with great value, great value for the customer and great service, because the two shouldn't be mutually exclusive. And I think the way we do that, if you look across any sector where technology and digitalization is causing innovation, what you see is that it's typically the companies that own their own technology and build their own platforms that can really disrupt. So you think about, your Amazons and your Ubers, and it's because they can have a symbiotic operating model and technology stack that means they can just move a lot faster than people who procure technology. And so that's how we've achieved our sort of rapid growth whilst maintaining amazing value and customer service. We built a technology platform called Kraken, which is effectively a sort of full stack energy retail management. And we're now moving into things like portfolio management, optimization, virtual power plants, etc. And we license that platform to some of the biggest utilities in the world. So E.ON in the UK, Origin in Australia, and some other UK and Australian retailers. So I think crucially, the challenge ahead is that particularly in sort of Northwestern Europe economies, most of the decarbonisation work that's been done to date has been done sort of out of view of the consumer. So that's increasing renewable generation, particularly. The consumer hasn't really had to do anything other than perhaps pay a little bit more in their bill to enable that. Now the next phase of decarbonisation is all about engaging the consumer, and so the challenges there are decarbonising heat, decarbonising transport. So you're going to physically have to change things in their home and the way they drive and charge their car. And to do this, you have to engage the customer. You can't do it without both their trust and permission. And crucially, we think, in terms of challenges, we need to be able to adjust demand. You can think about it in terms of all sorts of different structures, but really it's about maximizing the use of green electrons and minimizing the constraints of the network while you do that. So to engage customers and create great products, the first thing you need is trust and great service. And so this is a sort of a bit of a braggy slide from us, but to show you can't start to go into people's homes and you can't get them to sign up to these innovative offers if they don't trust you to bill them correctly and they don't trust you to answer the phone and give them honest answers. So we've worked very, very hard to achieve that. The second thing you need to do is actually start to build those engaging products, and it's the products that effectively allow customers to use electricity in a way that is both green and good for the system. So I'll talk you through one of our products here. This is what we call the Agile Octopus, and what it is it's a dynamic time of use tariff relying on smart meters, where the price depends on the wholesale price in the market, and we give 48 different price periods per half an hour, and we give that day ahead to customers. And what customers can then do is adjust their consumption. So you can see here on their bill, here's the price and here's their consumption, adjusting it out of the peak price period. And so that's good for the customer, they save money, and good for the grid because we're not overloading the system. We've found the ways that we can make this work really effectively are firstly to open up an ecosystem. So don't create walled gardens. We effectively produce this price signal through an API. which lots of people have integrated with lots of different companies, either hardware, people like battery companies, EV companies, but also interfaces, so things like Amazon Alexa, if this then that, or those sort of pseudo automation platforms. And we found that that's created a very rapid innovation on the kind of things that are interfacing. And then the other thing is, we've been told for years and years in the UK market that customers aren't engaged in energy. We actually think that customers haven't been engaged in energy properly. And the way you engage them is you give them really clear communications, very clear price signals, and very clear reward signals for when they do the right thing. And if they do that, customers actually are really, really good at engaging. And here's an example. So quite an involved slide here, but this shows in May we had actually the sort of inverse challenge of what you normally expect, which was we had too little demand on the system, which meant that we needed to turn demand up to basically soak up some of the renewables so we didn't have to turn them off and turn gas on for stability. And you can see here, this is our agile price in pink, and the wholesale price went negative through that period. And on this graph, you see normal customer usage. So these are all of our smart meter customers who don't have any dynamic price signals. So they're sort of oblivious to this price dip. Here you can see our agile customer prices, and they really pick up their power consumption. And actually, you see it's not just sort of them wasting power. That power consumption then comes out of this period here. Hoping you can see my mouse. And Duncan, who used to be in charge of all National Grid's operations, was very pleased that we could take power off the system when we needed to take power off the system. We recognise that one size fits all. I think the events in Texas have shown us that there is risk to the consumer with having dynamic pricing, and we think that it's not all about dictating one type of product for consumers. Actually, what we think is, there's different levels along the risk spectrum. So we've created a whole bunch of tariffs. The Agile Octopus is sort of on the dynamic end of it, where the customer is bearing more risk but getting more reward off the back of that, and maintains control of their devices. On the other end of the spectrum, we have a Tesla Energy plan, where we effectively control the devices with Tesla based on price signals that the customer doesn't see, and they get a fixed rate plan which is cheaper than market off the back of that. And then in the middle we've got EV tariffs, where you can choose your booking, you can book a window to charge in. We've got a fan club tariff, which is effectively a hyper local tariff which is dynamic based on the local wind turbine. And so I wanted to echo some of the thoughts we've heard earlier from the other panelists about like how we actually embed this as sort of mainstream in the market. And it's all about, for us, it's all about price signals of markets that reflect local context of the system in real time. The more we can get that, the more the assets can do the most intelligent thing for the system at the right time. We need to move from the paradigm of system operators who internalize all of their optimization, say, we'll work out what needs to be done, and then we'll give out the actions. Because if you do that, what you end up is with the system operator as a sort of gatekeeper of innovation. They're the only person who can create the type of signals or the innovative actions. So if you externalize the price signals, you'll get innovation across the whole spectrum. And then crucially, digitalization is important, but it has to be driven by the markets that it's there to enable. If we just digitalize the system, I always think it's like sort of having a supermarket with loads of fancy tills and scales, and all you're doing is charging customers a fixed fee to enter. So the market comes first, and the digitalization is the enabler. So that's all I have, I think, just in time. Thanks very much.
Thanks so much, David. Brilliant. I was particularly impressed that you got such a response in terms of the dynamic tariffs, because that's typically one of the issues that we hear, is that consumers aren't interested. They won't want to spend time following their energy usage. Demand is inflexible. The only way forward is to automate. but it's nice to see that there are a range of different types of perspectives and different types of approaches that can fit the large variety of users. All right,
Yeah,
I'd like to invite all our panelists back on stage for a brief discussion. And if I could challenge you a little bit. So if you were to wake up tomorrow with great to supreme decision-making powers, no budgetary constraints, and of course, as all of us here, you're interested in harnessing digitalization opportunities to accelerate the clean energy transition, what would be your first 3 executive orders or actions? And I'll leave the stage open. Please jump in.
I can have a crack first. Let me first slightly challenge the question, because I think the budgetary constraints is really important. If we don't have budgetary constraints, what we should do is just, reinforce all of our networks so that we don't have any physical constraint. But we clearly can't do that, because that's going to cost the consumer loads of money and is not the intelligent thing to do. So under the sort of physical constraints we have today, I would say we need to roll out cheap metering in the networks, and that needs to be driven by a sort of industry-wide global push to drive down the cost of metering the interior of the networks, particularly at a local level, because that's super important for understanding the network flows and how we can use markets to constrain them. Defining the DSO role effectively, and it was really interesting to hear about Sweden's sort of tiered DSO structure. I think that's fascinating, defining that really effectively so that we can get on and define the interface between ESO or TSO and DSO and retailers. And then sort of less digitization, but finding ways that consumers can invest their money today for green sort of transition type infrastructure in their home without ending up sort of out of pocket in the short term. So how do you sort of get that dividend for the consumer and bring it forward for them? And that's really a policy thing rather than a digitalization thing.
Thanks, David.
I can continue. I want to have standards for communication, SIM standard, and I want also to have standards for power of attorney. It takes a lot of time when you don't have standards, and it's a mess. So standards are really, really important. Secondly, I want to have some subsidy money to give money for flexibility. This would be very, very positive. And thirdly, and this is more out of my project, I think reserve power should be more integrated into the net planning. So if we can incentivize that the reserve power should not be isolated from net planning, and of course they should be, given money for participating. Hello?
Great, thanks so much, Yvonne. Yeah, I think you've put things very much on track with your 3 actions. Do we have any other takers for this question?
I agree with many of the comments of that Yvonne and David made.
Roy, if I could ask you to speak up a little bit, we're not hearing you well.
Can you hear me okay now?
Yes.
Okay, so I was saying that I agree with Yvonne and David that there are a lot of different actions that need to be taken, and they need to be done in a coordinated fashion. I wouldn't say that they are all technological. In fact, I think I emphasize the role of policy innovation and market innovation as an important part of making unlocking the flexibility of all the different types of resources. To make it really work, you need more data to be available. So smart meters, energy monitors, and figuring out where the data goes from there. And then I've spent a great amount of time working on the Common Information Model, which supports IEC 61850. It's a complementary group of standards that we really need to sort out the interoperability question. You might have noticed that NIST came out with version 2 of their interoperability roadmap just in the last couple of weeks. So I encourage you to have a look at that as well.
Excellent. Thank you, Amro.
I can jump in now. So I would second, in fact, David with his first comment, because my first solution was to invest and make it really mandatory to have cross-border interconnections, and also connecting to the events that happened in last week's in Texas, right? I think that interconnected markets and interconnected grids are super important because they can sometimes save us, right, in our region or in our country by importing electricity from other regions. And I think that European countries have taken really the right path to invest in the interconnection capacities, and to really make sure that these imports can cover really a big portion of the average peak demand of the country or the region. And of course, monitoring and managing this interconnectors, that requires a lot of digitalization as well, and to really optimize the electricity flows, the markets, that requires a lot of computing power and intelligent algorithms. And also sticking with the topic of the markets, I am a really big supporter of obligation to sell electricity through wholesale transparent markets. So I would put an obligation on every generator, on every utility, to really put 100% of their generation through a wholesale transparent market, where hourly or even quarterly changing prices for electricity really reflect the true value of this good at any point of the time. And I have the third example, which is from completely different bucket, because I'm a huge fan of sector coupling, and I really like that this example also popped up in the introduction done by Mr. Hernandez. And also looking at my personal experience of growing up in a not very rural, not very urban, on the other hand, area where no one had electric heating at home. And in fact, I have always lived in countries where no one had electric heating at home, but who had burners and were burning, in best case, coal, in worst case, no one knows what. So I would even like to couple the electricity sector with heat sector by, for example, building, say, waste incineration, cogeneration facilities, power plants that would be steered, say, from a virtual power plant, for example. And their goal would be, on one hand, to really supply urban citizens with heat and hot water that would be distributed to their homes via district heating systems. And at the same time, these facilities would be flexible assets that the power system operators would be able to use to provide ancillary services to really balance out the frequency in the grid. And I would like to put these facilities in each city in the entire world that has more than 10,000 inhabitants or something like that, because I really like the fact that at the same time we are combating air pollution, heat and heat deprivation and energy poverty, and at the same time we are building quite a reliable asset that supports the whole electricity system.
Thanks so much, Alexandra. Let's hope that Alexandra does wake up one day with supreme decision-making powers. John, do you have some comments?
Yes, yeah, just a bit flippant, but the first thing I would do is I would buy all the pencils in the world, because I heard a great talk about 20 years ago from a market designer in the UK, and he as he was giving advice on re-regulation for all the energy markets worldwide, he said, write your rules in pencil, because you will make mistakes and you will need to change them, right? So the other thing that I would do is, one common concern that I hear around the world is is I would empower a bit more of the regulators to be able to encourage coupling between the distribution grid and the transmission grid, because it's becoming increasingly possible through many of the solutions we heard described today at the distribution grid to influence the stability, security, and economic operation of the bulk supply network. But in many jurisdictions, there are still some regulatory disincentives to allow those investments and operations to occur. So, I think for the economists and regulators on the call, I would double your staffs, because I think you're in many jurisdictions, you're headed in the right direction, and I look forward to your continued progress in that area.
Right. Thanks so much. On that positive note, I'd close this discussion. Once again, thanks so much to all our speakers for inspiring, exciting, and thought-provoking presentations. It's been an absolute pleasure to have you here and to have the opportunity to discuss with thought leaders, with innovators, and to show all our audience around that what is possible, and that very much is possible, and that while we do often discuss barriers, and we've been discussing barriers and challenges today, the presentations today show that much more is possible than we typically think, and more things are becoming possible each and every day. So thank you very much, and we look forward to collaborating with you in other events and in other ways. I'll move over to some quick closing statements.
Thank you.
Thank you. Bye.
Thank you.
Thank you. So as we heard today, the imperative to accelerate progress on clean energy transitions is growing. Increasing ambition levels will call for unprecedented levels of investment and action by all stakeholders, and digitalization will play a core role in enabling this transition. And today, as I mentioned, we've had the opportunity to hear from frontrunners and innovators, both from the policy sector, from academia, and from the business side, that have given us great opportunities to learn and gain insights. A few of the points from the discussions that I'd like to emphasize that really pressed home the value of strategic approaches and effective institutional structures, the need to collaborate across silos, across boundaries, and key issues to consider, of course, understanding vulnerabilities and tackling these systematically, understanding the value of data and putting in place mechanisms to enable data access and the effective use of data, of course, while protecting personal data and ensuring that cybersecurity threats are effectively addressed. That the importance of identifying and sharing benefits and communication of benefits, we really heard that this can either block progress or be a complete game changer. And of course, aside from finding ways of more effectively working together, both within the power system, but also with other systems, culture change and the importance of continued education and improving the accessibility of digital solutions and improving the understanding of the benefits that can be unlocked. Another few key highlights that I heard is that digitalization, of course, it's a tool. It's not the goal in itself. And there's a need for systematic and concerted actions in terms of unlocking the opportunities. In this context, markets and price signals are absolutely crucial. If we're not able to assign a value to flexibility resources, to the services that distributed resources can offer to end users, to distribution companies, to the power systems as a whole, we will not be able to progress. We got some great insights into markets for flexibility, but one critical point there was that steps are needed to make sure that the value proposition is attractive, and price alone might not be enough. Of course, we need enabling regulatory and policy frameworks. And this really drives home the whole discussion that it emphasizes that there is a great value for platforms and opportunities to, at an international level, share best practices, innovative approaches, experiences. There's much to be learned from seeing what other countries have done, the mistakes they've made, the challenges they've encountered, and thinking about how we can all, in our different contexts, leapfrog and speed up the transition. So on behalf of the Clean Energy Ministerial, Power System Flexibility Campaign, and the International Energy Agency, we thank all our excellent speakers, and we thank all of you for joining us today and for being so active in the chats and in the questions. We will be taking a note of all your comments and all your insights. And it's been a productive discussion. There'll be some really great ideas on how to accelerate progress. And we very much look forward to continuing to engage with you all over the coming months and years. Please consider yourselves part of our community of friends of digitalization for energy transitions. And we very much look forward to discussing with you over the coming months and years. Thank you very much for joining us today.